Today we are going to perform an experiment. So experiment in the sense we are going to play with data. Okay. So we will try to record data with data acquisition system. So I already told you that we are going to use our system DEC card and DEC device, DEC chassis from the National Instruments. Okay. We already discussed. So the question was, what is the time domain data and frequency domain data? We were discussing about time domain data and frequency domain data, and I told you that if everything is changing in this three-dimensional space with respect to time, so in that sense we can say that is in time domain data. That is time domain data. Okay, like that. See, suppose that this is time. Okay, and something is changing. Something is changing at y-axis. Okay, so I am putting word data here. Okay, data and time. Time is flowing in this direction and we are recording data in this direction at this level. This is 0 at this level. Okay, you can give me example. Suppose that we are measuring second. Okay, second also is not continuous. It's tick, 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 like that. See, this is in digital format, okay, not changing continuously. But if something is changing continuously, like pure sinusoidal signal, okay, see, this is changing continuously. But digital data, we are going to deal with digital data. So in digital data, what's happened? Suppose that, as in this experiment, we are interested to record acceleration, okay. So time, what we will do, we will add 0, we are not going to record any data, okay. At very small time interval, delta t is very small, even it can go up to nanosecond, microsecond, it will depend on the accuracy of your system. So at 0 second, we will record our data, okay. You are getting my point? Time, first sample, value of that data, okay. At beginning, what is the acceleration? Okay, then we will go one step ahead, delta t one more step. So this data will look like that. Okay. So this data is digital data because there is not continuity, and we are going to deal with this kind of data. So there is two things. If you are dealing with these kind of data, then you have to keep in mind two things: sampling frequency and bit accuracy of your device. So what is sampling frequency? Can you tell me, Saurabh?
Sir, sampling frequency is the rate at which we are going to collect the sample. For example,
okay, per second, how much data point we are going to collect? That is called sampling frequency. Okay, suppose that in 1 second we are going to collect 5 samples. Okay, then in the sense we are planning to collect only 5 samples in 1 second. So our sampling frequency will be 5. If we are planning to collect like that, let me show you very interesting phenomenon. Where is the duster? Okay. This class is going to be very interesting. See, suppose that we are planning to record pure sine wave at 1 Hz. See the difference between sampling frequency and the frequency of real data. Okay, I will try to explain what is the difference between sampling frequency and frequency of the data. Suppose that real data was, so in nature everything happens generally in continuous form. Okay, suppose that something is changing like a pendulum. Okay, we are performing an experiment related to pendulum and we are getting data in this format. Okay, so as I told you that data may be displacement, it may be acceleration, it may be the velocity, doesn't matter. Okay, because differentiation of sinusoidal, you will get sinusoidal signal. frequency remains always same. Okay. So like suppose that I am interested to record this data. So this is 1 second. Okay, this is 1 second. Then my frequency of data is 1, because in 1 second it's completing its complete cycle. So frequency of my data is 1. Now the question is sampling. What is the sampling frequency? Suppose that I plan to sample at 3 hertz. How much hertz? 3 hertz. So in same time interval I will record one data point here somewhere. Agree? I will record some data point here because I am sampling at 3 hertz. I will record one data point here. So what we are doing, we are just recording data. After that we will reconstruct these points. So when we will reconstruct, what we will get? A single line. Data was a sinusoidal pure signal, but now because of the sampling frequency, even our sampling frequency is 3, but still we are getting simple straight line. Just think about 5 samples. Okay, 5 samples. So if 5 samples, then we will put one more sample here, one more sample here. So one sample here related to this sample, one data point, this one, this one, this. So when we will reconstruct this signal, what we will get?
Triangle.
See, this is the sampling frequency. See the beauty of sampling frequency. Signal pure signal, this is pure sinusoidal signal. Even frequency of this data point is 1 hertz. When we sample at 3 hertz, we were getting a straight line. When we sampled it at 5 hertz in the sense, in 1 second we collected 5 data points. That is the sampling frequency. Okay. Then after reconstructing those data points, we are getting a triangular shape signal. Okay. Let's increase more samples. Okay. Then you will get little smooth signal. Okay, you got it? Now it's matching little bit with sinusoidal pure signal. But even we should increase more and more samples to record correctly. Okay, but still by sampling at 10 hertz to 15 hertz, we can get almost sinusoidal signal. Now there is one very famous theorem, criteria actually, Nyquist criteria. But if you are interested to sample something at n hertz, the real data is vibrating at the real frequency of data is n hertz, then at least minimum sampling frequency should be 2 times of that frequency. 2 times. But here in our case, even 2 times is not enough. Even 3 times is not enough. So that's why we are sampling at higher frequency. You got it? Now sampling frequency is clear? Sort of?
Yes, sir.
So now question is, what is the bit accuracy? And why we are much worried about the bit accuracy? If we have good samples, if our sampling frequency, if we can manage sampling frequency, then still I am talking many times bit accuracy, bit accuracy, bit accuracy. So what is the bits? Suppose that I am telling you 2-bit system. What is the meaning of 2-bit? Saurabh, what is the meaning of 2-bit, 3-bit? Tell me, anyone, including you. What is the bit accuracy of system? Bit in the sense 2, 0, 1, okay. These are bytes. So bit of system, suppose that I am telling you n-bit system. So n-bit system in the sense, steps, how many steps we can measure to the power that particular bit. 3-bit system in the sense 2 to the power 3. So what is the 2 to the power 3? 8. In the sense we can discretize, we can collect something, okay, we can record something at 8 levels. I will tell you, I will explain by this graph what is the levels. So if I am telling you that 4-bit system, then we can record data at 16 levels. So now what is levels? So we will learn same, we will use the same sinusoidal signal at 1 hertz with 2-bit system, 3-bit system, 4-bit system. Suppose that Generally in digital electronics we play with 5 volts. Okay, general. We can play with 10 volts also. Suppose that this my system is 5 volt system. Okay. So minimum value will be 0, maximum value will be 5 in our case. Okay. This one is 5 volt. So what is label? In the sense this is 0 label, 2 label. If I am telling you only 2 labels, in the sense 0 and 5. You can record either at 0 label or you can record either 5. Okay. So suppose that I am using 2-bit system. Okay. In the sense 2 to the power 2 labels. 4 labels. Here 4 labels. In the sense you can record data at 4 labels, in the sense 0, maximum is 5. So 4 labels now. So you just divide 5 in 4 labels. 1.25. And here
2.5.
2. This is not exactly exact. Okay, you are not able to divide. Okay, leave it. But are you getting? Because now in this system there is gap of 2.5. So just try to divide this 0 to 5 exactly. 1.33 I think.
3.7.
Huh? 1 point?
1.3.
Okay. 5. 1, 2, 3. Just divide 5 in 4 labels.
5 in 4 levels, then 2.
2 point? No, not 2.6. So 2 labels, just 2 labels, 5. Okay. Divide in one more label, 2.5.
Yeah. 0 to 1.25, then 1.25 to
1 point
2.5,
25.
then 2.5 to 3.75, and then 3.75 to 5.
Okay. This is okay?
Yes.
0, 1, 2, 3, 4. Okay. So suppose that we have these much labels. Okay. And our sampling frequency is very high. We can record at very much very high sampling frequency. Okay. Then, but we have only bucket of 1.25 liter to 5 liter in the sense term of voltage. So we can only record at the level of 1.25. So below 1.25 you will record as a 0. Okay. So at this level you will record as 0. And 1.5 to 2.5 you will record as 2.5. Agree? So your data will look like this. And from this point to this point you will record signal. Okay? And below 5 you will record signal like this. So what you are saying that you are recording even with very high sampling frequency. You have very high sampling frequency, but still your data is not good enough. So that is the bit accuracy of system. You are getting what I am saying. So you know earlier I explained what is the sampling rate. Now your sampling rate is suppose that 200. So I am just discussing about 200. So before this, all the samples you are recording at the 0 level. Here you are recording from this point to this point. Suppose that you have 50 samples, but still you haven't bit accuracy. So you are recording all the samples at same level. You are getting, now it's clear what is the bit accuracy. So you are recording data in staircase like structure. Okay. Suppose that you wanna improve this also, then what you can do? You can increase bit accuracy of system. So So generally, very cheap microcontroller like Arduino, bit accuracy is 8-bit system. Okay. So in how many levels you can record data? 2 to the power 8. It's I think 216. 256. Okay. So 256 in the sense 0 to 5 voltage you can divide data in 256 levels. Okay. But our system, this is much more accurate. Okay. So we will record to the data at 12 bit. Okay. With 12 bit accuracy. In the sense 2 to the power 12. It's I think 4096. So what we will do, we will divide 0 to 5 voltage in 4096 levels. Okay. Even we can divide more, but today we are going to use only 12-bit system.